Why do I write mathematical papers? Why do I write mathematical papers? I got non-mathematical video here. Mathematics is a language. I should never forget that. I will never forget that. I use it to communicate ideas between me, myself, and I. That is me, Uche, myself, Eze, and I, Obi. I use it to communicate ideas because formally mathematics is a language, so I use it to communicate ideas between me, myself, and I. It is me, myself, and I communicate with. Like a spreading relationship between the real world and internal. Because I build for the real world. I don't build for the specification per se. I build for the implementation. The specification on the implementation of the real world. For example, the white paper. I write white papers and doesn't matter what I'm building, my method is involved in everything anything I'm build because my method is a formal language to express and communicate ideas between me, myself, and I internally. Because I have three diaries. Um, I use it to uh, architect, describe systems, conceptualize innovations, and model the world we live in. I use it to describe um, uh, an architect or architect and describe systems, conceptualize innovations, and model the world we live in. So that's why I use mathematics. Today, that's why I use mathematics. So I use it to describe architect, basically to build the world around me in a formal model. I use it to express myself, me, myself, and I. But it's more than because it can be put into code. So the next phase is the proof, and the proof will convert into code. But the code can be translated back into physical world, around me. It's private systems because it's like a pipeline. It's a pipeline. It's a procedure. So it's a procedure that I get something out of. And for me to remember that's how I work. Doesn't matter I have money or doesn't matter I have money or not. I use it to build a better build proofs to describe systems. That's why I love mathematics. I just use just to write my own papers because I can have, for example, the ontological Bayesian intelligence or Lepolical. These are hypotheses, lemmas, things that say, for example, I want to build an AI system, AI model. Where do I start? I start by researching AI. But if I want my AI to do something different, because this is an end goal for me in mind, and that is to achieve something in the real world. So I use it to describe my architect and describe systems. Systems, yes, describe systems of things happening around me. Systems is two or more components working together. Any two components that work together, that is my definition of system since I was as a child. But systems can get very complex very fast. In based on the application of what you're doing. But two components that work together is a system because they can get complex very fast. But can you ask why these two components working together? What does this component do? This component doesn't. Is there a relationship between this component and uh, another that keeps that may cause pitfalls in the system? Think about the questions too. You know, Um, so the model of the rule is very explicit because it's how my brain functions because I have ADHD type 2, and everything comes to down to modeling the problem precisely with mathematics. I have a plan. I use mathematics creatively. I have a plan. I use mathematics to formally notate the systems precisely. Yes, because mathematics allow me to precisely identify the problem or describe the problem mathematically. Because if I write it down formally in formal language, my method will allow me to express there is a problem to be addressed instead of English. I still love insipidity. Um, for example, um, to prove a solution exists in our world, in the world all around us, like the solution exists in the kind of because when you're building for the real world, you're building actual theory. From when I build that, it's like I don't digress into theory. I digress into what's achievable in the current state and that in current now. And now is in the real world. Now in the present is the real world. Like building systems of innovation systems. So that's what I got here. No, this is not good enough. So let me try and give myself an example. Let me try to do some mathematics. Let me start with the hypothesis. Then let me continue. Let me start. Let me continue with either one of my projects I'm working on, or, or start with a new hypothesis. Because I'm going to give you an example of how I do this mathematically. This is my notes basically. This is my notes here. Okay, see guys. Let me. Excuse me. Um. I could say describe. No. Let me start with what I want to build. So I want to build, yes, a haptic feedback robotic system. So the cybernetics haptic feedback, because these are old former technologies. But this one of the things I want to really want to build. Basically, a cybernetics haptic feedback, uh, 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 component module. So I put here a cybernetics happy feedback module. Let me start with a problem statement. In a problem statement, frame like this. It's not actually. Uh, so the problem there exists a need. This is my problem statement by the way. There exists a need for precision. Let me get Audacity. Actually, I'm just opening Audacity up. Okay. There exists a need for precision, such that this is just a mathematical terminology, but it's English layman's English term. Let me show you what I mean. There exists a need for precision, such that uh, robotics systems which uh which deliver um, um mail, groceries, and other essential items in the real world, which are still learning, require which are still learning, requiring a human in the loop when they fail, i.e., a robot delivering essentials, food, water, shelter, posts, mail, post, may is capsize, may capsize, like may tip over, may tip over, then tip over when training in the real world. So basically, a robot just falls over. When training, when training occurs in real ontological Bayesian intelligence, an AI system. So this is problem statement. So the problem statement reads this: there exists a need for precision such that a robust system, which are delivering goods, groceries, and other essential items, is in the real world, which are still learning, needs a human in the blue when they fail, when they trip over, because they're trained on the real world, so they trip over, they fall a lot. They fall a lot. This is hypothesis, like it's like it's not a hypothesis, it's like thing. So because I'm basically training AI ontological Bayesian, this is my own work, and remember, this is my own work. So this is the name of my own work. Bayesian intelligence. No mathematics yet, just the problem I'm trying to identify. Training in the real world. In the real world. Um, we need uh, a novel solution. I mean, it's a very simple solution. A novel solution is to implement a haptic, haptic feedback, real time. Basically, cybernetics is real time because it's real time. Cybernetics feedback loop to engage to uh to reset the ontological Bayesian intelligence system to stand by in a standby state to continue its operation. So this is a problem that is from so when my robot trips over, it can come back up. When a robot trips over, we just use a haptic like a basically what's the example of haptic video obviously. Basically, when you play a video game, haptic video systems are in these controllers. No, basically these are not really haptic feedback. They are the old edition 4. They are haptic feedback, but I've never experienced it. But these are have haptic feedback in them. Yes, I did experience it. So this could have haptic feedback. Basically, they react to your sensor. They sense they sensoring your input, and they are exporting they have haptic feedback loop. So it's like an arm. Like you don't control an arm, but you control an arm with one hand. But you have your hand and some kind of augmented reality, some kind of augmentation to your hand that gives something. I call it augmentation because it's based on augmented. I call it augmentation based on augmented reality. But if you have some kind of device in your hand, you use control another hand extend like an operation, like have performed some sort of surgery. So I say precision and I say haptic feedback loop. So I said three things. The keywords are position of the central system, which a haptic field. It's a listen. You're gonna have haptic field. You're gonna have a vision module. Gonna have so I'm gonna develop a vision module. So let's start with the things to define. So this is three to design a vision module, like in a component module, a physical hardware a hardware vision module, a cybernetics visual module. I can use a state machine, a finite state machine. Use a FSM, finite state machine. Basically, the feedback will be cybernetic. So if you want a cybernetic, you go real time camera, real time camera, real time camera that basically pixel information as soon as it's there. But you know, you don't have to program it explicitly. You can have a 360 camera if I wanted to pan around 360, but there's gonna be a blind spot and there's a blind spot problem. So use a finite state machine. But I'm not clear this about to here. I've noticed that. So I said I'll do the mathematics today. Let me get to the mathematics. So what's the fact? So the problem was there exists need for position, need for human in the loop, while training or debugging or surgery. These are called you know, these are the kind of this thing. When you have when you have a cybernetics works by feedback loop. So if you have a component contains to B, doesn't matter if it's like if you have a component like a component A connects to B to C, A goes to B, B goes to C, and C returns back to B. That's cybernetic interface because the feedback loop to the system. It's real time. Everything real time because you know system can run code in real time. So on the fly. So this is like a visual model. So this is like my diagram here. I don't like the term A to B to C. Sounds kind of simplistic, but it's a model of the world. So A connects to B to C, where A, B, C are all modules. But you know, but see how C loops back to B. This is cybernetic interface. So if C has an output, if C has an output, any kind of it goes to buffer brain, like you know, basically like basically what I'm saying is this version, this is cybernetics feedback loop vision system. Because the module um should I call it B to A? I'm just calling it B to A. So this is a system here. So this is a cybernetic system. So you know this is a feedback loop system, but you know only on cases it's a cybernetic cybernetic non-haptic feedback loop because you know doesn't matter if it's pressure, if it's sensing is pressure, or it get response in real time, you get the update in real time. Any kind of update is triggered in real time because the system can account for the component I had before it to relay that information in real time. And that's the idea. So it's A is connected to B, B is connected to A, and A to B, and B to C. B to C. But C has a feedback loop to B, the component, which relays back to C. And B and B has a feedback looks back to A, which relates to B, because the information is what's protected. So you can run some kind of a cybernetic, what called cybernetic algorithms. So you can update on the fly. You can execute on the fly. This is basically you can execute instruction whilst the system, like, you know, if you want to run some kind of like you know this code at some threshold, you can do that at exact interval of that threshold. Like you know, like a thermometer. That a thermometer. Yeah. So this is why I love mathematics. So for me, I've created a model here. Now let me do the mathematics. So let me do my so. I'm gonna remove A, B, C are all big components. I'm gonna remove just lowercase. I can make a state machine diagram. Because I can design an FSM for it. So let me design an FFM. So pointer A to B, B back to A, to C back to B, and the output is the circle. So this was state machine diagram here. But this is one example. Now this is not really addressing a problem that the visual module, just a design architecture it is designing, but there's no problem I've defined properly. So maybe because when something is instance of some kind of threat, it yields at some interval, it executes some instruction at an interval. But that's the idea between cybernetics. I'll give you an example. The cybernetics, what it means to us. So haptic feedback goes the same way. Haptic feedback loop works the same way as a cybernetics, but just for sensors, for your touch or your taste, or for things that do handle pressure. So a haptic feedback handles like touch, like a sensory or pressure, push or pull, or handles force, acceleration, thrust, uplift, thrust up, thrust down, thrust left, thrust. So these are all problem identified to express that there are problem solution spaces here. So I'm going to do some mathematics here. So the mathematics I'm trying to do. So this is such a big problem. It can be broken into smaller problem. I can decompose it. I can decompose this problem. This is a long video. So the problem was cybernetic robotic systems human. So when a robot fails to halfway, it has to be getting up. So so basically instead of me, I have a suit. So basically the goal is to design a suit that I power on. So I power on my suit and use to control the robot. It can be something that's augmented. I call it augmented because it's not real. So you get augmented reality. Augmented reality. I have to get on augmented reality. Augmented reality is a digital information onto the real world, enhanced perception without replacing it. Okay. So if I have enhancing my perception of the system, that's an augmented system because it enhances my perception of the reality of the robot. So if I have a problem system, so let me continue from because I'm not thinking rubbish here. To design uh, an augmented so this is a solution I can start working on cybernetics, haptic, feedback, suit or system, suit, suit. Like a kind of it can be a suit. It can just one solution to a problem, or that I wear to ensure that the robots are uh, can can continue the operation or tasks provided in real time. Because I then basically I take control of the robot, take control of the robot systems in the robot. Because I want my children to be based on robots, so together. So that's the idea there. So I'm now sitting now. Now I know what to do. I'm setting to up to the video. So no mathematics is written down. So let me do some mathematics. So let me just model the robot. So let me model the robot. So we can design a suit, or we can implement uh, computer vision, uh, uh, a computer vision. No, a computer. This is one difficult example. Let me to computer camera that with controls to that adjusts the robots uh, um, uh, 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 that take control of the operation the robots do. Robots are doing are performing. So I can implement some kind of so I can take my computer and put some kind of a system that I can take the mouse and key, uh, the computer program. Yeah, these are all simple stuff. But I can have a suit which is even more cool, or I can use my computer, my mouse and keys, commas to my computer program. So, implement a computer program that will control the robotics hybrid. Yes, this was what I said. Yes, that's what I said. So this I really got this problem sorted out. I call it a hybrid directed instruction system. This is a system. This is basically a polyglot based system that will enable the music controlled robot, whether by mouse and keys or by robots or by haptic feedback cybernetic suit. So the mathematics is not done yet. So let me do more mathematics. So the mathematics of the mathematics of this would be a polyglot, a core module, uh, uh, which is a physical component, which is the robot itself, a core module, a core module, a foreign function interface layer, a computer module, a computer component I can control, a computer program with a joystick. I'm not thinking about this properly because you see, I'm thinking of too cool stuff. I'm thinking what I can do, what I can't even do. So design a cybernetics interface that ensures that the operation continues operation. Implement a component program with a joystick. With a joystick. It has to be with a joystick. With a joystick. So these are two solutions there. So the joystick will have buttons. Let me get my arcade stick. I do have an arcade stick here. So I can have an arcade stick used to control robot, or use a controller to control it, or implement a controller. They have many options that can deal with what is being. If that's the problem, or if I want to work precisely with the component, if I want to work precisely with the components and the real world, the robots can't do it, and this is basically human. It basically captures human. It will build something that better. So get an ontological vision system. So this is a hybrid direct instruction system. So let me do. I haven't done my analysis yet. I'm too embarrassed. Okay, so what about this be? In a real environment, so if a trial one, trial two, if the AI tries twice and fails, this can be a case for transferal or trial three. So trial one, the AI fails. Trial two, the AI fails. Trial three, human in the loop initiated. Or this is one example case. This is case and point. Case and point. Or purpose and point. And then trial two. So trial one, the AI fails. Trial two, the AI fails. Trial three, get a human to do the job. Like giving surgery, like a surgeon. Um, try one, try two, try three. I can't wait to go to Nigeria. The UK. Sorry about that. Hybrid doesn't hybrid just means it works across a polyglot layer, uh monoglot, polyglot, and hybrid. Uh, Directed means direct instruction set. Basically, there's one core instruction that for that module, and system directed instruction like RAM modem, RAM, random access memory, DRAM, direct instruction, random access memory, which is one of my projects, and systems, which are systems components working together. I haven't done any mathematics here, but I've done more. Okay, I've done mathematics here, but I've done all the mathematics here, but I haven't done any right formal notation. So I can now start my formal notation. So let me start my formal notation such that a feedback loop. So a cybernetic feedback. You can start with a threshold. So let's define a cybernetics, a haptic feedback loop is a cybernetics feedback as well. Is a cybernetics feedback loop with using sensors. Sensors to detect the rule based on the via uh classification of sensory actions, control of sensors via dimension DTT to the link. So let me define it. So I'll go to maths here. I've done more this paper. I've done more maths than I actually needed to do my maths. So this I've done my maths here. I have to put in a formal language. So basically, all this I've done is the maths. I know you tell me it's not maths because I know I've done here. So the exist position. I can start with the integral calculus. I can start with a series. I can express it anyway mathematically and fun. So let me try to limit. Limit as monotonically let me try two different. So I've done the math, I guess, let me try to form as a hybrid direction. So this is a hybrid direction system. So I have to feel so trial one, trial two, trial three. I can take control of trial two, but it fails to trial three, hands me control, and alerts the human. So if an system fails to achieve a task in the role, it will have to be a trial three, a trial two, or trial three. Because your trial one just means it's doing the one. So hands in trial two. So these are trials, these are event trials. So let's call it event trial. E is an event. No, T is a trial equals to a tuple E T sub n is equal to or T is a function T n is a function of E. uh, Tn is a function of E events. Basically, you want three trials. Let me do it properly. A trial is a number of events. So let's define a problem. A trial is executed number of times, executed number of events. This is basically our convention. So that T equal to executed T given such that E given V. Oh, T such that N given E. This is a function T trial is noted as such given such that this is trial equals to N number of events less than. I can do a Frankie function here. I'm doing it very poorly, but I'm doing it my way. So a trial, what's a trial? A trial is executed number of events. Uh, trial one, trial two, trial three. So trial is T such that N E or such as E. Oh, let me get define. Let me define them. A trial is a series of a sequence of events. Sequence of events. It's a sequence of events. A trial is a sequence of events. So, sequence is defined as T such that T equals S T equals S sub V. Yeah, no. So this equal to, it's literally equals to, this is what we definitely will do, but it's not expansive. It's not you will look at this one where T is where uh, uh where N T sub M, where T sub M is equal to, where T is a trial, and is a number, S is a sequence, E is an event. So that's all I needed. It can be a sequence or series of events because that means it's homogeneous, but it's still a trial. So trial one, trial two, trial three, and the system hands off control to the system. So that means hands off. So if I define a function, T equals a sequence S E S sub E uh, 14. So that's my T. So hands off, H, a function HT such that function HT such that uh, T is defined, hands off the function H, hands off T stands for trial, changes the controller, changes the actor, the person being controlled in the handling the trial. So that means I have to expand my definitions. You see what I'm saying? Because I didn't just go through the definition, I have to go through the definition. So, T, so get T is a trial, H is a hands off, H stands for hands off function, O stands for operator, S stands for sequence, E stands for events. The hands off function is hybrid direct instruction. Hands up the instruction set, hands up logic of the instruction set to the operator. So operator, up OA and OS. This is just like operators. Operators are people that actually operator uh, uh operator is basically operator defined as a human can be O H or O T is a trial, H is a hands off, O is the operator, human or AI. S is a sequence of instructions in the event. So basically, I've now defined the problem. So now I'm gonna stop talking and start writing the stuff down. So when a trial fails, a trial can fail. Fail. So trial one failure. Trial has let me say, okay. Let me define it from a trial is four trials. For every trial, no, there exists. No, so for all trial, there exists, there exists an operator such that O is for trials, there's no operator. Oh, for all operators, there exists a trial T, such as T, uh, uh, um, how do I do a franking function? I can't remember how to do a franking function. T is an M of success, failure, and a hands-off O, such that O is an element of AI system. Let's call it system for S or human in the loop. HITL system, sys or HITL, human in the loop. These are my definitions. For all trial, hands up or such that it's an element of system or human loop. For all trial, for all events, uh, 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 for events, for events belonging to or belonging imply for events or belonging to for trials and events belonging to HOP now is now belonging to uh uh HITL. I'm feeling it. So, basically, I've done very poorly. Well, very well, actually, not very poor, like you said, very poorly. But I've done my job. So that's why I use my work exercise. Use it. It can be completed a bit more, but this is basically a haptic cybernetic feedback loop system that can take control of the system when a truck and AI system fails horribly. Thank you for watching the video. Or use control, use for precise operation or surgery, like surgery or things that are dangerous in the real world.